This question gives us the average self-reported happiness index for people who earn similar annual salaries times $1,000. So for folks between 30 and 40,000, where the middle point is 35,000, the happiness index was 3.88. Between 40 and 50, or a midpoint of 45, the happiness index was 3.78. 55 represents those 50 to 60, index is 3.82. So that's how these numbers were generated. You'll notice I have the link to the Forbes article that gave us these numbers. This one here at 125 would have been between 120 and 130. But this one at 225 would have been those between 200 and 250. So you get the idea. We have all of these numbers in the first column correspond to salaries, and those in the second column correspond to the happiness index. So we want to do something with these. We want to see what the relationship is between your annual salary and your happiness index. A higher happiness index is a higher degree of happiness, just so we're clear there. And we're going to choose to use a logarithmic function this time to fit the data. And we're going to want to determine the happiness index for someone earning 25,000. So notice that's not on our list. We started with 35,000. And the other question is, use this model to predict a salary needed to have a happiness index of 4.5. You'll notice the highest one we have here is 4.21. I assume the scale went up to 5. So is getting to 4.5 reasonable? How high will that be? So we're going to go ahead and put these numbers into the graphing calculator and then do the appropriate regression. So I'm going to go ahead and pull that up. So going to the graphing calculator, stat, edit, and I'm going to click, okay, we have things there. So second quit, stat clear list, L1, which is second one is L1, clear list L1, and stat clear list L2. So that we'll remove the numbers that are there. And then I need to plug the various numbers in to the graphing calculator. So let me see if I can do that. 35, 3.88 is what we start with. So 35 was first, and then 3.88 was second in the Y column. And then the next one we had was 45, 3.78. 45, 3.78. So I have a whole bunch of these to fill in. So I will do that. I'll plug those in, and then we'll do some analysis. So I have plugged all those numbers into the calculator, which you can see now. So I've filled out that table. There are a total of 22 pairs of numbers. And as always, you should check to make sure that you've put them in correctly. I like to look at a graph, a scatter plot, just to get a feel for how these numbers are related to each other. So I'm going to turn the stat plot on. It currently is on, which is good. And I'm going to go to zoom stat, make sure there's nothing stored in y equals. There's something from before, so I'll clear that out. I'm going to go to zoom stat, number 9, and we'll take a look at that. So that's the relationship of the annual salary and the happiness index. And what are we supposed to do with this? What does the question ask us to do? Well, looking at this, it says, find the logarithmic function that best fits the data. So we're going to go ahead and do a logarithmic regression and determine that equation. So back to the calculator. Stat calc, and number 9 is a natural log regression, so that works. So we'll go ahead and hit enter or hit 9 for the natural log regression. The data is in L1 is my first column, that was salary. L2 is the happiness index. It's not a frequency list. I will store it in Y1, vars, Y vars, function Y1, and then I will calculate that and see what that regression equation is. And I lost it for some reason. Let's do that one more time. Stat calc 9 log regression. We'll store it in Y1 again. Vars, Y vars, function Y1, and we'll calculate it and try not to have it erased from the screen this time. So the equation is Y equals A plus B natural log of X. That's the model that we're using here. And we have A is, again, keep a few decimal points, otherwise we wind up with errors. 3.3243, maybe I'll go with 3.3243, and B is 0.12526. So our equation would be then, using these variables, Y equals 3.3243 plus B 0.12526 natural log of X. But what was Y? What was X? What did we have? Remember, the X value was the salary number, and the Y value was the happiness number. Remember, the salary number is times 1,000, so just keep that straight. So I'll just go ahead and I'll say our salary number, I'll call Sal, is, check that. One more time, let's look at that. I realized my error there. The Y value is happiness. Y value is happiness, the X value is salary. We're predicting happiness from salary. So Y value happiness, which I'll call hap, is 3.3243 plus 0.12526 natural log X, but X again I'm going to replace with Sal. Sorry, I wrote that so poorly. I'll write that down one more time. Hap equals 3.3243 plus 0.12526 times the natural log of that salary number that we're dealing with. So what did our question ask us? What were we supposed to do? It says, predict the happiness index for someone earning $25,000 annually. If it's 25,000, the Sal number is 25. We can see that, I hope. So let Sal equal 25. What is our predicted happiness index? 3.3243 plus 0.12526 times the natural log of 25. So we'll jump to the graphing calculator to actually do that as we go back. We get 3.3243 plus 0.12526 times the natural log of 25, representing 25,000. And the predicted happiness index is 3.73, we'll call it. Now, how does that compare to the other numbers that were close to that salary amount? As we look, 3.88, 3.78, 3.82. So we would expect it to be lower than those, and it is. 3.73 is lower. Now, there's another way we could have done this. Remember, I stored the regression equation in the calculator. I stored it in y1, so I have y1 equals this now, which if you look at the whole thing, a long time to do that. It should end with natural log x, of course. I'm going to go ahead and I'm going to graph it. And there we go. I'm going to go ahead and graph it. I'm already in Zoom stat, so I'll continue with Zoom stat. And it looks like, here we go, Zoom stat number 9. And that's going to fit the logarithmic regression equation into the points that we have. Now, there's an awful lot of these that are way off, right? Higher than predicted, lower than predicted, higher than predicted. Most of those are pretty close. We do have those 3 numbers that are not behaving quite as well as the others in terms of how close they are to that prediction line. Okay, now, what else we can do is I can actually get that number for 25,000 by plugging that into y1. So I could say vars, y vars, function y1, evaluated at 25. And I expect it to be about 3.73, and it is. Okay, I believe I have one more question to do here. And what does that say? Use this model to predict the salary needed to have a happiness index score of 4.5. Okay. So how are we going to do that? We have our equation here. Happiness scale is modeled by this equation. So if I want the happiness scale to be at 4.5, right, we'll say 4.5 equals 3.3243 plus 0.12526 times the natural log of x, or salary, is what we're dealing with there. Remember, that was our original equation up here, I guess, is the one that I should be focusing on, right? So for replace 4.5 with the happiness index, what's the salary we need to get that? Step 1 is to subtract the 3.3243 from both sides. Where does that lead us? 4.5 minus 3.3243 gives me 1.1757 equals 0.12526 times the natural log of the salary. Next up, divide both sides by the 0.12526. That divides out, leaving me with natural log of salary on the right side. On the left side, I have 1.1757 divided by 0.12526, and I get 9.386. I like to write the log on the left, so I'm going to write natural log sal equals 9.326, 386. Remember, the base of the natural log is e. So e to this, e to the 9.386 will equal the salary. So e to the 9.386 is going to equal the salary. So what is e to the 9.386? 11920 approximately. Now, what does that mean? Remember, that was in thousands. So how much of a salary would you need to get that happiness index up to that? And again, it's not really fair to extend your model that far beyond the numbers that we have. But to answer our question as it was phrased, to have a happiness index of 4.5, this model requires a salary of about 11920,000. So if you're not clear on what that is, that's almost $12 million. Wow. So that's a big jump. And again, this kind of regression going that far beyond the numbers you're given is called extrapolation. And in statistics, you're told that that can get dangerous, that your models break down, that they're really best served within the range of the numbers that you have. But extending this model out, that's as far as it requires us to go to get to that happiness index of 4.5. So let's take a look at our function one more time. Remember, this is our graph. And I want to know, how far do we have to go to get to 4.5? So if I put a happiness index of 4.5 and I ask myself, where will that graph intersect 4.5? You can't even see 4.5 on my window. So I need to adjust this significantly. So we'll make the max 5 so we can see 4.5. This gives you an idea what we have. And there's 4.5. How long is it going to take to grow to get there? Well, quite a ways. First, I'm going to go ahead and turn off my stat plot so that I'm not seeing all those points. And you know I need to get to 12,000 or so. So my X on my window, well, we'll graph it first like this so you can see. There is the log regression equation, and there's the 4.5 we're heading to. So we have a long way to go to get there. I need to get to beyond 12,000, so I'm going to make my X 20,000. And we're going to see where these two graphs intersect. So there's my log function going way out. Here is my 4.5 happiness index. I want to see where they intersect. Second calc, intersect. First curve, good. Second curve, good. Yes. Again, we hope the answer is 11,920 or thereabouts. What do we get? Pretty darn close to 11,920. So $11.9 million about is what you need to earn to have a happiness index of 4.5. But again, you don't really want to use these models that far beyond the numbers that you're given.